Bismillahir Rahmanir Rahim. Energy. The ability or capacity of a body to do work is called energy. The energy is measured by the capability of doing work. It can be in the form of potential energy or kinetic energy. So energy of a body is its capacity to do work. There are two basic forms of energy, kinetic energy and potential energy. The kinetic energy is possessed by a body due to its motion and is given by the formula half mv square. So kinetic energy depends upon the mass and speed of the body. Potential energy. Energy due to change in its position, or it is a stored energy. When we move some body or mass in the gravitational field against the gravity, then we have to apply some force or we have to do some work against the gravitational pull. And that work can be calculated by the formula force into distance. As force is the weight force, mean W is equal to mg, and the distance is h or the height. So that work will be equal to mg into h. And this work is actually the potential energy which is stored in that body. Work energy principle. When a work is done on a body, it increases its energy. Consider a body that is moving with the initial velocity vi and the force F is applied on it over some distance d. Its final velocity becomes Vf. As force, when force is applied on a body, then it pushes the body and it accelerates the body according to Newton's second law. And the force is applied on a body, acceleration is produced. It means velocity is increased. How much velocity is increased? That is Vf. Initial velocity was Vi, final velocity is Vf. And as we know that, we have moved that body to a distance d. According to second equation of motion, we know that 2as is equal to Vf square minus Vi square, where s is equal to d. So putting the values of different parameters, we get distance is equal to 1 over 2 acceleration into Vf square minus Vi square. As we have applied the force F on the mass m, so we can write F is equal to ma, where a is the acceleration produced in that mass. And we also know that Fd is equal to, by putting the value of force in this formula, half m into a. What is the a? By putting the value of acceleration from this equation, the final equation becomes consider a body is moving with the initial velocity vi and a force F is applied on it over a distance d. Its final velocity becomes Vf. As the velocity is increased from its initial velocity because of this force. So we can apply these parameters in the second equation of motion. What is the second equation of motion? 2as is equal to Vf square minus Vi square, where s is the distance. So we replace s with the d, which was moved by the body during the force application process, and we take this value of d to the right side in the denominator using cross multiplication, and we get the value of acceleration from this equation. We know that F or force can be written as F is equal to ma by putting the value of acceleration from here into this equation. Work done can be calculated using this formula, where F is the force and D is the distance. Putting the value of F from this equation, half m, and from A, D will be cancelled with the D. The result will be half mvf square minus half mvi square. This is known as work energy principle. So what is the work energy principle? That total work done will be equal to the change in kinetic energy, as we have proved in this slide. That work done is equal to change in kinetic energy. If the network is positive, then the kinetic energy increases. If the network is negative, then the kinetic energy decreases. At last, we prove the formula for kinetic energy. Consider a body of mass m is moved from the rest by applying some force F to a distance d. It means work is done by this force. And this work will produce the kinetic energy. How much kinetic energy is produced? We can calculate in this way. Initially the velocity is 0, and after applying force the body gets a velocity v. Putting the values of velocities in above equation, we get total work which is equal to kinetic energy, half mv square. It means any body, when work is done on that body, the work will produce a kinetic energy which will be equal to half mv square. So kinetic energy is equal to half mv square. Thank you for watching the video. Please continue watching video lectures on thecancollege.com.